Good morning, everyone. My name is Puneet Kumar C, and we will be presenting our research work entitled Noise and Silence Removal with Keyword-Based Speech Indexing in Audio and Video. So, this work focuses on improving multimedia quality using AI-based speech enhancement, silence removal, and automatic speech recognition with keyword-based indexing techniques. It also supports translations for other languages, and it also generates the summary of the video. So our paper ID is 106 and our project guide is Dr. Chaitra N, Bindu S, Veera Shamargatti, Hemavati VM, and Puneet Kumar C. These are the authors of this research work. So this presentation is organized into the following sections. First of all, we'll talk about problem statement till conclusion. We'll go through all these concepts one by one. So multimedia contents play a major role in today's digital world, especially in online education, virtual meeting, entertainment platforms, corporate training videos, etc. So basically, these raw multimedia recordings often contain long silence gaps, unwanted noise, and background noise. And these noise and silence affect the video quality or audio and video quality and the understanding. So long silence segments reduce the user interest and continuity, of course, and lack of transcripts makes the content non-searchable. For example, if we have a recording of the Zoom meeting, we can't just jump to the exact part where the user has said some specific word, and no translation for other languages are available. So these are the problem statement of your research work. And one more thing we have added is a summary of that particular multimedia content. After processing, we can get a summary of that particular video with which user can understand with studying those materials, and also we are generating a assessment based on that particular video. So if you come to the objective parts of our project, the main objectives are as follows: to develop an AI-based multimedia processing framework which will remove the unwanted noise, environmental noise, ambient noise, and long unwanted silence part in audio and video. And it also improves speech clarity, which enables users to access to the great quality of that particular audio and video, and convert speech into accurate timestamps, transcripts using Whisper ASR. And it also enables fast keyword-based navigation for long meetings and long online classes. And it also generates multiple translations. It currently supports 12 Indian languages and 2 foreign languages. And it also provides AI-assisted summaries with question and answer and assessment generation. And it reduces manual effort through automated multimedia editing. So to address the limitations of existing multimedia systems, we are proposing an AI-driven multimedia processing framework. This proposed system is an integrated framework that combines speech processing techniques and NLP techniques for great and good quality audio and video consumptions. So it performs noise reductions, silence removal, speech to text conversion, keyword extraction, and content generation with which provides a summary of that particular audio and video with the assessment generation for educational videos. So this approach reduces the manual effort. We don't need an video editor to do all the editing works. They will take care of everything. So this is our proposed system. So the system consists of 3 main modules. The first module is noise and silence removal, which improves speech clarity. And if you come to the second part, which is keyword-based speech indexing, which will convert speech into text and maps the keywords to timestamps, which enables searchability of this particular video. And finally, the third part, which is Video Insight Hub, which generates the summary of the particular video, and it will provide the assessment for that particular video also, so the students or corporate guys can easily go through that content and get their evaluation done quickly. So this is the proposed methodology for project. This slide shows a complete workflow of the system. First, audio or video files are uploaded. Then audio is extracted using FFmpeg and normalized to 16 kilohertz mono format, which is the required format for our model to feed. And then we are using DeepFilterNet and Demucs models to remove the environmental noise like background noises, ambient noises, fan noise, traffic noise, etc. And then we are using voice activity detection, which is also called as VAD, which removes silent regions in the audio or video with a specific threshold. And after that, in the fourth iteration, we are using Whisper ASR, or automatic speech recognition system, which converts speech into timestamped transcriptions, which is very helpful for our next feature, which is keyword-based speech indexing. And then we are using TF-IDF vectorization, which is term frequency and inverse document frequency. Keywords are extracted from transcripts, identifying important words in multimedia content, and which is helpful for keyword-based speech indexing. And then in sixth iteration, we are implementing translations to other languages. Currently, it supports 12 Indian languages and 2 foreign languages. We are using gTTS, Google's text-to-speech, to translate one language to another language, and then it supports multiple languages, as I said. And then in seventh phase, we are using Groq API and a T5 transformer to generate this summary of that particular video, and it will also generate assessment and question and answers based on that particular video's subtitles. So then we are combining everything using React frontend and Fast API backend, which is a web application. So these are steps in our methodology. First of all, we are feeding audio or video files into our framework. Then we are using FFmpeg, which is fast forward moving picture experts group. Using FFmpeg, we are extracting the audio from video, and then we are resampling those extracted audio files into 16 kilohertz mono format. And after that, we are normalizing all the sampled files for consistent processing. And then we are using a custom fine-tuned DeepFilterNet model trained using Muson, which is music, speech, and noise dataset, along with Demucs to suppress the stationary and non-stationary environment noise and ambient noise, like the fan sound, traffic noises, etc. And after that, we are using energy-based VAD, which is voice activity detection, using FFmpeg to detect silence and trim that silence part. So after that process, once a speech is converted into text, TF-IDF and scikit-learn techniques are used to extract the important keywords from the transcript, which is essential for keyword-based speech indexing. And these keywords are mapped into timestamps, which helps users quickly to navigate through the important topics of the video. And these transcripts are also used for multilingual translations using Google's text-to-speech APIs. And after that, we are using Groq API with T5 transformers to get the insights and summary of the video. We are also generating assessment and question and answers for that particular summary, so the user can go through that content and get their knowledge tested. So this slide explains the core multimedia processing modules. Here, audio pre-processing is done using FFmpeg with 16 kilohertz normalization, which is essential for our DeepFilterNet model. And we are custom fine-tuning the DeepFilterNet model integrated with Demucs, which removes environmental noise such as traffic noise, fan noise, background noise, etc. And then voice activity detection, also called as VAD, removes silent segments while maintaining the audio and video synchronization, which is the most important part. And then the second module is speech to text and keyword based indexing. Here, Whisper ASR, automatic speech recognition, convert speech into timestamp transcriptions. And after that, we are using TF-IDF and scikit-learn extract important keywords from the transcripts. This slide explains the multilingual processing and educational analytics modules of a framework. For multilingual subtitle and audio generation, we are using MarianMT, which generates subtitles in multiple languages. After that, we are using Google's text-to-speech, also called as gTTS, which is used to generate translated audio for translated subtitles. And then the system also maintains synchronization with the original multimedia content. Currently, it supports 12 Indian different languages and 2 foreign languages. And our next module is Video Insight Hub, which is an educational analytics module. We are using NLP techniques and T5 transformer models to analyze the transcripts. Then the system generates summaries, Q&A, and assessment automatically, which users can understand the video summary and take an assessment to know their knowledge regarding that video. So this is our implementation slide. The system was developed using Python 3.10 with deep learning and natural language processing frameworks. We designed the framework using a modular architecture, which makes integration, testing, and future scalability easier. So audio extraction and pre-processing are performed using FFmpeg in 16 kHz mono format. For speech enhancement, we are using a custom fine-tuned DeepFilterNet module trained using approximately 10 hours of Muson environmental noise samples. The training data included traffic noise, ambient noise, fan noises, classroom chatters, and other real-world background noises. Then DeepFilterNet was integrated with Demucs to suppress both stationary and non-stationary environmental noise. Finally, VAD, or voice activity detection, using FFmpeg silence detect removes unwanted silent regions while preserving the audio and video synchronizations, because without synchronization, all the processing doesn't make sense. So this slide explains the remaining implementation components of our framework. So we are using Whisper ASR, automatic speech recognition base model, which is used to generate timestamp transcriptions from the enhanced audio. And after that, we are using a TF-IDF and scikit-learn for keyword extraction and timestamp based multimedia indexing, which is very important for our keyword based speech indexing. For multilingual processing, MarianMT generates subtitles in different languages, and Google's text-to-speech, also called as gTTS, generates translated audios. And then, as discussed earlier, we are using T5 transformer modules integrated with Groq API, which generates summaries, multiple choice questions, assessment, and also evaluates, so the user can take the knowledge test for a particular multimedia content. The framework was evaluated on approximately 3 to 5 hours of real-world multimedia recordings under different conditions. We also manually inspected the output with the original input also. This slide shows the result and performance evaluation of our framework. The graph compares system performance before and after implementation. After applying the proposed framework and methodologies, speech clarity improved significantly due to effective noise suppression, and SNR, or signal to noise ratio, also improved from 8.2 decibels to 21.6 decibels. Word error rate, also known as WER, reduced from 29.8% to 12.5%, which indicates better transcription accuracy. Also, subtitle accuracy improved from 74.6% to 91.2%. Also, the translation accuracy improved to 88.7%. Similarly, keyword extraction accuracy reached 93.1%, enabling high and efficient multimedia navigation. AI chat relevance and assignment relevance also improved significantly after integrating the educational analytics framework. Overall, the results demonstrate that the proposed framework effectively improves speech enhancement, transcription quality, multilingual ability, and keyword-based multimedia indexing effectively. So this slide explains the validation methods used to evaluate our frameworks. We have used signal to noise ratio, SNR, to measure the speech enhancement quality. Then word error rate, or WER, was used to evaluate transcription accuracy. Then keyword extraction accuracy was validated by comparing the extracted keywords with manually annotated reference keywords, which is important because as a developer, we should know how our module is performing. We should include manual testing in some part also. So then silence reduction accuracy was verified using manually checked silence audio segments. Then subtitle and translation accuracy were evaluated using multilingual multimedia samples. We also compared our framework with existing baseline models. For speech enhancement, we compared against RN Noise and Demucs. For automatic speech recognition, we have compared with Vive2 Vec2 and Google ASR. For silence detection, we compared with Energy VAD and WebRTC VAD. Then finally, for keyword extraction, we compared with RIG and Keybird. The proposed framework achieved better signal-to-noise ratio, low word error rate, and higher keyword extraction accuracy compared to existing and baseline methods. In conclusion, the proposed framework successfully integrates noise removal, silence trimming, and speech processing to improve multimedia quality. Also, our Video Insight Hub framework will generate effective summary with question and answers and assessment to test the user's knowledge about that particular video. It generates accurate transcripts along with keyword-based navigation, making the multimedia content searchability easier. And then this framework also supports multilingual subtitles and translated audio, improving accessibility for users. By automating multimedia processing and educational analytics, the system reduces manual effort significantly. There is no need of a video editor for these kind of tasks. Overall, the framework transforms raw audio and video recording into organized, searchable, and meaningful multimedia content with strong application in educational and multimedia systems. Thank you for this opportunity. Thank you for listening to our presentation. We always welcome your questions and suggestions.